Assalamualaikum dear students. So we are here in the second lecture of our topic, that is fractions and decimals. So if you haven't seen the first lecture, I will instruct you to go there and watch the first lecture first. First lecture, then only you will be able to understand the second lecture here. So have a look here. This is lecture number 2, fractions and decimals. The last time we have left it or where we have taken the topic, that is types of fractions. So we have done a few. So this was the topic, types of fractions, where we have explained 3 types of fractions, that unit fraction, proper fraction and improper fraction. Let me remind you, unit fractions are those fractions whose numerator is whose numerator is equal to 1. Numerator is equal to 1. Any fraction having numerator equal to 1 is a unit fraction. Then proper fraction, those fractions having numerator less than the denominator. This is something we have already done in the previous lecture. Then improper fraction, those fractions having numerator greater, or you can write greater or equal to denominator. So a fraction having numerator greater or equal to denominator are called improper fractions. You may get confused, sir. It will be equal to, suppose, sir, in case of, when we take the case of improper fractions, suppose, sir, it is 5 divided by 5. So can we call it an improper fraction when the result it will give is equal to 1? That is the whole number. That is the whole. That is not a part, because we have already known that fraction is a part of a whole. But remember here, that definition that I have provided you, that is actually the initial definition, that is actually the basic definition of fraction. But then we came to know that any number that is in the form of a by b, any number that is in the form of a by b where b is not equal to 0, we can call that number a fractional number. Whether that is 5 by 5, whether that is 5 by 8, whether that is 8 by 5. They all are fractional numbers. Yeah, among all these numbers, this fraction here, 5 by 8, is the proper one. Rest 8 by 5 and 5 by 5, they both are improper fractions. So these 3 types of fractions we have already done in our previous lecture. Now we will move to the 4th type, and the 4th type of fraction, that will be on the other side of your screen. So here it is. I am now coming to its types of fractions, continues types of fractions. And now we are moving to 4th type. 4th type of fraction that I will take here is mixed fractions. Now let me come to mixed fractions. Now what are mixed fractions? And with that, I will add one more thing, is 5th one, sorry. 5th one I will carry on here is equivalent fractions. Let us first discuss these 2 types of fractions. Mixed fractions. See, the name itself suggests that there might be something mixed. Which makes it. Now, what are mixed fractions? They are actually the combination of whole and a proper fraction. Combination of whole and a proper fraction. Together, when we take them together, they form a mixed fraction. So, I am writing here combination and proper fraction. Now example we are carrying here. Let me write 5 1 by 3. 5 1 by 3. 5, you know that the whole part, and 1 by 3 is a proper fraction or a unit fraction, we can call it as well. So their combination, this whole number is known as a mixed fraction because it is the combination of whole part and a proper fraction part. Next example I will take 10 3 by 8. So this again a mixed fraction because it involves whole part 10 and a proper fraction 3 by 8. So any number that is the combination of whole and a proper fraction part, they together form mixed fraction. Now we have some important questions regarding this. Let me first clear these mixed fractions, and since have a look here. Mixed fractions can be converted into improper fractions, and improper fractions can be converted back to mixed fractions. How? I will consider example. I am writing here I will take a question here. Convert 10 3 by 8. Here this number I am taking 10 3 by 8 into improper fraction. So 10 3 by 8, I need to convert it into improper. Remember, every mixed fraction can be converted into improper fraction. So I've taken one example here, 10 3 by 8. Let me try to convert it into mixed fraction. I'm writing the solution. Whenever you have to convert an mixed fraction into improper fraction, what you have to do? You have to take the mixed fraction 10 3 by 8 back. Actually, what is this 10, what is this 3, and what is this 8? You will come to know once we will convert improper fraction into mixed fraction. Now here, all you have to do, it is actually what it is. You have to, basically it is 10 plus 3 by 8. Whole part 10 plus the fractional part, proper fraction part 3 plus 10. Now usually what you used to do here with this question, you may not have the idea when you have to add a fraction with a whole number. How you used to add, that will be shown in the same chapter later on. But here you have to keep in mind, you need to multiply the denominator with the whole part. Multiple, and whatever is the result, add that with 3 and keep the same denominator. Denominator will never add. See, I will write 10 into 8. So whole part multiplied with the denominator, then plus adding the numerator. 10 into 8 plus 3 and whole divided by 8. What actually is happening? It is whole part. It is whole part into denominator plus numerator, whole divided by denominator. This is the rough portion here. Now, what will this happen here? 10 is 80 plus 3. Sir, why we are multiplying first? Why not add? You are aware. I hope you are aware about the board mass rule. So first multiple, then add. Whole divided by 8. 80 plus 3 is 83 divided by 8. Now check up what type of fraction is this. It is numerator is greater than the denominator. So we are able to convert the mixed fraction into an improper fraction. Now I will take one more example here. You can take the screenshot of the same, so that I will copy one more example where I will convert the same improper fraction back to the mixed fraction. Now have a look here. Now I will take the opposite of the same. I will write here question, convert improper fraction that is, let me take the improper fraction 83 by 8. It is an improper fraction into mixed fraction. So let me have a solution of the same. You have done these type of questions in class 6. I am just recapitulating the things. Now the improper fraction given here is 83 by 8. You know what actually is a fraction? It is basically another form of division. अब देखो बेटा यहाँ पे 83 by 8 you may have done in your lower class 83 divided by 8. So you are aware that this is the dividend and this 8 here is the divisor. Now what you used to do, how you used to divide, that is denominator you have to keep out and numerator you have to keep inside the box. Numerator is always a dividend and denominator is a divisor. Now starting up the long division method. I have to convert improper fraction back to the mixed fraction by, we can convert it by the long division method. Have a look. Now 8 1 are 8. Or you can write 8 10 are 80, but 8 1 are 8 you can write. Now 8 minus 8 is 0. Now this is 3 down. 3. But you have brought this 3 down from the box. So whenever you are bringing the number down from the box, you have to use an 8 0 or 0 as. If it would have been the remainder of subtracting the two numbers, 8 minus, suppose 8 minus 8 3 are, तब आपको यहाँ पे 0 से करने की जरूरत नहीं थी. But since you haven't divided 3 को हमने divide किया ही नहीं, but it is already less than the divisor, so you have to take 0 here. 8 0 or 0. Now 3 minus 0 is 3. But this 3 and this 3 having different episodes. Actually, this 3 comes when we subtract the two numbers, and this 3 was directly brought from the box. So it is 10, 3 and 8. 8 is the remainder, 10 is the coefficient, and this 8 is the divisor. Now, what is the mixed fraction here? Therefore, mixed fraction. Remember, mixed fraction is always of the form Q, that is coefficient, R by D, remainder by divisor. Now, if we take coefficient R by D, what will be our mixed fraction? Plus coefficient is here 10, remainder is 3, by D is divisor 8. So this is the mixed fraction जो हमारा था 83 by 8. In the check it in the previous example where we have got improper fraction 83 by 8 from the mixed fraction 10 3. Now we convert the same 83 by 8 into the mixed fraction, we get back 10 3 by 8. This is the recurrent mixed fraction. So whenever it is mixed fraction, remember it is the whole part of the coefficient. And the numerator part is the remainder and denominator part is the divisor. I hope you got this example. So you can take few more examples. You can have these examples here. Now I'm coming back to the board. You can have 5 3 by 9. You can convert this into improper fraction, then back to the mixed fraction. Now this was mixed fraction. Simply combination of whole and proper fraction. Then with it we came to know how to convert mixed fractions into improper fractions and improper fractions back to mixed fractions. Now one more type of fraction here is equivalent fractions. One of the important topics as well. So we will come to it. So word equivalent suggests something that will be equal. Remember, every fraction is having infinite possibilities to get those fractions whose value will be same as the original. Suppose I am taking your value, I am taking a fraction 1 by 2. When you find its value will be equal to 0.5. Then one more example, I will take 5 by 10. Its value, when you will check, it will again be 0.5. Then one more value, I will take 25 by 50. Its value, when you will check, it will again be equal to 0.5. So there are infinite possibilities to grab up those fractions whose values are equal. Now the fraction 1 by 2, 5 by 10, 25 by 50, and lot of fractions having the same value of 0.5. All these fractions are called equivalent fractions. In sorry fractions, we write down equivalent fractions here. Now, if you have to define equivalent fractions that look from their numerator and denominator, they will look different. Fractions that by the presence of their numerator and denominator, they will look different. See, 1 by 2, 5 by 10, 25 by 50, they look different. But when we try to find their values will come out to be same. इनके values हमेशा same होंगे. So 1 by 2, 5 by 10, 25 by 50, they look like different. But जब हम इनके values निकालने की कोशिश करेंगे, their values will come out to be such type of fractions which look different by their numerators and denominators, but give same value after calculating that. After simplifying, they will give same value. Those fractions are called equivalent fractions. See, sir, how? 5 by 10 if you take, it does not see any fraction whose cancellation is possible. That is not considered to be the standard fraction unless and until you will not do proper cancellation there. Here I can write 5 1 are 5, 5 2s are 10. So value will still be 1 by 2. In the same, you can do cancellation here. 25 ones are 25, 25 twos are 50. Again 1 by 2. 1 by 2, 1 by 2 and 1 by 2. All these values give same equivalent fraction. All these values give same fraction back. That's 1 by 2 after doing big simplification. Now that simplification can either be the cancellation that we call division. Cancellation is another form of division. Short form of division. That simplification can either be done by the division that we call cancellation, or sometimes can be done by multiplication. The first I will write the definition of the same. So let us move to the back side, one more slide here. So I am coming to third slide. It was, I hope, third, fourth, fifth it is equivalent fractions. So let me write it, fractions having same values. Those fractions having same value are called equivalent fractions. Example, you can pen down the example here. I am writing 100 by 200. I am writing 50 by 100. I am writing 1 by 2. These are the first equivalent fractions. They all will be equal to 1 by 2 after doing a bit cancellation. Next, second one. I will take 8 by 12, 16 by 24, 24 by 36. So these three fractions are equivalent fractions. These three fractions are also equivalent fractions. Now the question is, how will we produce equivalent fractions? For that, I am having an example. So example I am writing. Write 3 equivalent fractions of 5 by 7. So I have been asked you to find 3 equivalent fractions of 5 by 7. Now you have to first see solution I am writing. If the given fraction is already in the lowest form, that is, if we do the cancellation of these two numerator and denominators, is that possible? You can clearly see that here. Whenever the cancellation of the cancellation of fraction is not possible, it means we have to find the rest of equal fractions by multiplication. Now I am writing first. It is 5 by 7. How will you find its equivalent fraction? You have to multiply its numerator as well as its denominator. As well as its denominator. By same number. It's your choice what you will do. Whatever number you will choose. But it is better to move in a sequence. So I will take 2 at the top and at the bottom as well. It is still balanced. If you multiple something in the numerator, you have to multiple same thing in the denominator to make the thing balanced. Now I am using 2, so why not 1? Because in previous chapter you came to know that 1 is the multiplicative identity that will not alter the value of the number. So we fill some 5 by 7 in opposite. That will be filled. Now 5 2s are 10 and 7 2s are 14. It is also a fraction. But this 10 by 14 and 5 by 7, they look different by their numerators and denominators. But their values will be same. Whatever the value of 5 by 7 will be, same will be the value of 10 by 14. Now, this is the first equal. I need 3. Second one I am taking, same 5 by 7. I will multiply this numerator by 3, then it is denominator by 3 as well. So 5 3s are 15, 7 3s are 21. So 15 by 21 is same as 10 by 14. It's also same as 5 by 7. It looks different. Value is the same. So the third one, I can write 5 by 7 into 4 divided by 4. You can multiple numerator by any number, but the number that you will choose in the numerator, same number you have to choose in the denominator. 5 4s are 20, divided by 7 4s are 28. So this 5 by 7, 10 by 14, 15 by 21 and 20 by 28. They look different by their numerators and denominators, but their values will be same. So they all are equivalent fractions. 5 by 7 was initially given. Rest 3 are 10 by 14, 15 by 21, 20 by 28. This is how we will get equivalent fractions of any fraction by the process of multiplication. But I told you it can be done by division also. For division, let me come back. Now one more question. I am writing right 2 equivalent fractions of, I will take the same one, 20 by 28. Now there is a fraction here and it is not in the simplest form. That is, its cancellation is possible. Whenever the cancellation is possible, there are both methods applicable. You can find the 2 equivalent fractions by multiplication as well as by division. But here we have taken the case of multiplication. It is better for us to take here the case of division. Sir, how will we come to when we have to do multiplication or division? That will be given in the question. Question will recall whether you have to find equivalent fractions by multiplication or by division. If it's multiplication, you have to use this method. If it is division, then whatever I will pose the answer here, you have to do that. You have to do that. But if it is not written, it has been written only right equivalent, then it's your choice. But you have to think, if it is not possible by division to get the required number of equivalent fractions, suppose 10 निकालना, but division is possible नहीं होगा. The best way is to go with multiplication. I am writing a solution. Sorry. Now to find the equivalent fractions of 20 by 28 by division process. Division is another name of cancellation. Division means you have to actually cancel them. by their equal common factors. Whatever is common factor between 20 and 28, उनसे आप इसकी calculation कर सकते हैं. Now what I am doing here, have a look. So I am not taking a division process, I am taking cancellation process. I know 20 and 28, both are coming in the table of 2, starting with the ones. Whenever you have to find equivalent. Otherwise, whenever we have to do cancellation only, और हमारा एक concept नहीं होगा equivalent का, that time it is your choice. You can take the cancellation by bigger number. Now 20 by 28, they both are coming in the table of 2. 2 10s are 20, 2 1 are 2, 2 4s are 8. So I'm writing here cancellation by 2. And I got the first equivalent fraction, that is 10 by 14. You can see here, 10 by 14 was here in the previous question as well. Now second one, it is again 20 by 28. I need the second equivalent fraction. So what I am doing here, initially I have done the cancellation by 2. If I will do the cancellation by 2 again, I will get the same equivalent. Now I need to choose any other number. 3, they will not come in the table of 3. 3 is not the common factor of both numbers. So better is to go with 4. 4 5s are 20, 4 7s are 20. So it is equal to 5. I will write here cancellation by 4. And I got one more equivalent fraction, that is 5 by 7. 5 by 7, 10 by 14, 20 by 20. It was also here 5 by 7, 10 by 14, 20 by 20. They all are equivalent fractions. So this is the first one, this is the second one. So this is how you will do it by the division process. That is the cancellation. So equivalent fractions, fractions having same values. They look different by their numerators and denominators, but their value will be same, like here. And then the first thing that we have done in the previous slide, I can show it here. Here we have types of fractions. First, mixed fraction, we have done combination of whole and proper fractions. You can write combination of whole numbers, etc. Fixed number, because in mathematics we have to usually do with the numbers, deal with the numbers. Combination of whole numbers and proper fractions. We understood how to convert mixed fractions to improper fractions and improper fractions to mixed fractions. Then equivalent fractions, we came to know what actually are equivalent fractions. Then we are here, we just done how do we get the more equal fractions of a required fraction. It is either by multiplication or by the division. Doing the division, doing the cancellation by the same number, or doing the multiplication by the same number to both numerator and denominator. Now we are going to the next slide. Here we are having one more type, sixth type. I am writing here, it is like fractions, very important. Like fractions. Now see first, when we have done unit fraction, it can be a single fraction, 1 by 4 a unit fraction. Proper fraction, 2 by 7, proper fraction, single fraction can be a proper fraction. When we talk about improper fraction, 7 by 2, improper fraction. Single fraction can be improper fraction. When we talk about mixed fraction, it can be 8, 3 by 5, single number of mixed fraction. And when we talk about equivalent fractions, it can't be single. When you use word equivalent, it means you have to use at least 1 by 2 and then 2 by 4. They are equivalent. We have to take 2 here. So in case of unit, proper, improper and mixed single. But in case of equivalent, when we come to the concept of equivalent, it's not now the deal of one fraction, it's more than one fraction. And here the sixth law, that sixth type, that is like fractions. Like fraction, when the word like comes, it means we are not dealing with a single fraction. We are dealing with at least more than one fraction. 2, 3, 4. Now what are like fractions? Like fractions are those fractions whose denominator is equal, apart, irrespective of what is their numerator. So fractions having same denominator. Example. Example I am taking. I can write 5 by 7. If you take it, it is a proper fraction. But calling it a like fraction alone, that is not just 5. You have to take one more fraction and 8 by 7. See, this is proper fraction, this is improper, but their denominator is same. They both are like. We can call them like. So numbers, fractions having same denominator. This is the first example. Second example I will take 8 by 99 and 1 by 99. And remember, it's not necessary that one should be proper and one should be improper. It can be two proper fractions. It can be two improper fractions. Second example. Same denominator here. So they are like fractions. Third example. I will take 5 by 8 and 3 by 8. So they are also like fractions. So like fractions simply those fractions have the same denominator. Then seventh one, just opposite of the same. It is unlike fractions. Now we will deal with unlike fractions. Let me erase this here so that we will get a space to write the rest of the things. Unlike fractions. Let me tell you one thing, this will be the last type of this lecture. Last part of this lecture, and we will carry on in the next lecture, the rest part of the chapter. Unlike fractions, it is just the opposite of like fractions. Now you can just write a definition for yourself. Fractions having different denominator. Those fractions having different denominator are called unlike fractions. Example I will take here. You can take just the reciprocal, or just you can invert. उल्टा कर सकते हो आप जो ऊपर आपने like fraction. It is 7 by 5, comma 8 by 7. आप देखो 7 by 5 का reciprocal, लेकिन इसका नहीं, इसका 8 by 7 ही लिखा सीधा. But still they are what? Unlike fractions. Why? Because their denominator is different. Second example. You can take 99 by 8, comma 99. Now the confusion is clear. It was 99 by 1, but 1 didn't make any difference. 1 will not make any difference at the bottom, at the denominator. But I told you, even since it can be put, 99 can be put in A by B form. When you are dealing with fractions, you can consider it to be a fraction. Though it is not following the actual definition of fractions, but since it is in the form of A by B, to make it easier for us, every number that can be put, particularly when you are dealing with fraction, that can be put in the form of A by B, can be considered as fraction in that sense. Third example, I am taking 8 by 9 and 8 by 21. See, their numerator is same, but numerator hardly matters. It is the concept of denominator. So it is the concept of denominator, whether it is unlike or like. So 8 by 9 and 8 by 21 is having different denominator, 9 and 21, so they are unlike. Now, last thing I want to tell you, remember that, keep that in mind. That's very important. That will help us in the next part of the chapter when we go for the operations of fractions. Remember, we can add a remark I am writing here. We can add fractions, not only add, sorry, I am reading add but writing get. We can add or subtract. Add or subtract. I don't have a space here. We can add or subtract fractions only when they are like. So whenever you are operating the fractions by add and subtract sign, you are doing addition or subtraction of fractions. You can do it only when they are like, when they are, their denominator will be same. If they are unlike, then you have to make the denominator same by considering either the cross multiplication method or by the LCM method. Otherwise, we need to carry LCM method to find, to make, sorry, D stands for denominator equal. So the very important remark here, we can add or subtract fractions only when they are like, otherwise we need to carry LCM method to make denominator. D stands for denominator equal. So unlike fractions, that is the case of unlike fractions, you have to go for the LCM method to make the denominator same, but if it is like fraction, you can add them directly. Sir, any example? You can come to the example when we move to the topic. If you touch in the terminology, there is the topic, operation of fractions, here we will learn all these things. So this is all for in this topic, in this lecture number 2. We will come back soon in the third lecture. See you in the next class. Take care. Allah Hafiz.